Let's get started, shall we? Okay. Before we get into the session, let me just tell you a little bit brief about the company that I'm working now, so that you get an understanding of why I'm talking about this topic and why we're all here. So the current company that I'm working in, it's called Turf One. What we do here predominantly is we design, build, and we maintain sports field. So, so the local councils here, when I say local councils, it means the local government. It's very similar to the municipalities we have back in India. So these councils, when they want to build a sporting avenue or anything for that sort, when they want to build a building or anything, they'll put out an open tender. So this company is a civil contracting company. So like us, many other contractors, they'll go in and submit their bid. If the council is happy with your pricing, and if they are happy that okay, you've got enough capacity to do the job, then they'll award the contract to you, and then you'll get the chance to go in and build the job. So I'm assuming that a lot of you must be interested in sports, football, soccer, tennis, netball, volleyball, all of that sort. So I'm just hoping you all will be interested in learning how a sports field is built. Okay, let's go. This is all the overview of the things that we're going to be seeing today. I'll be talking about earthworks and how drainage works is done, and what the pavement profile is for different games. And then I'll talk about some synthetic systems. I'll explain all that in the later bit. And then I'll talk about some sustainable solutions. So this is just a bit of an overview of what the things that we're going to be seeing today. Okay. Before I start, I'll tell you how sites are being allocated for sporting venues. So when the Australia is not very much populated, it's mildly populated compared to many parts of the world. So there's still a lot of land developments going on in and around of Melbourne, Victoria, Sydney, everywhere. So when they decide that, okay, 10,000 residents or 20,000 residents are going to be occupying a particular area, they will, it's mandatory for them to say that, right, if so many number of people are going to be occupying a particular area, then we will have to allocate certain number of recreational spaces for them. What I mean by a recreational space is it can be a sporting venue, it can be a dog park, it can be landscape areas, it can be anything of that sort. So it is mandatory for them to allocate these spaces so that people can go in and keep themselves active. So that's how, on a community level, that's how we could acquire the sites, that's how the sites are being allocated for sporting activities. If you can see the presentation here, I've got a existing survey model or survey plan for a job. Actually, this was one of the first jobs that I worked in when I joined in this company. The council wanted us to build 4 soccer fields. 3 of it was synthetic and 1 of it was hybrid. I'll explain to you in the later part what a synthetic field is and what a hybrid field is. So anyway, if you look at this drawing, sorry. If you look at this survey plan, the surveyor would have picked up all of the features of that land. He would have picked up the roundabouts here. He's picked up all the pavements and the road areas. And he's given all of that as a digital model to us. So there are lots of factors that come into play when you want to decide what the finished surface level of your field has to be. I'm just going to point out or explain to you the key ones. I'll just explain 2 of it to you and why. There are 2 factors. So the first basic thing that will happen is they'll go in and check what are all the existing infrastructure that's close by. Factor is flood zones. So when a council or a local government, when they're going in and they're deciding that, okay, we want to build a building, or even if they want to build a sporting venue or something, and if they are aware that historically that particular area has been prone to a lot of rainfall, or it's been prone to a lot of flooding previously, then they will go out to a consultant and say, right, can you please prepare flood assessment report for us? So they'll have that report in hand. And also, if you see this drawing here, if there are creeks and catchment areas that are in very close proximity to your construction site, then there's a possibility, or more of a possibility for flooding to occur. So that happens. So this drawing this image that you're seeing in the presentation, it's actually a page that I took out of a flood assessment report. This was for a job that we are tendering for at the moment in Sydney. So the council, since they were already aware that they wanted to, that this area has been prone to a lot of flooding. So they went out and already did a flood assessment report by themselves. So usually when we get contracts, it's actually of two types. Either you have to design and build it, or you just have to build it. Most 60-70% of the time, the council would have already done a drawing for us, and they'll just hand over the design to the contractor, saying that here you can just go build what's on the drawing. But sometimes you also get design and build drawings where the council will just do the basic requirements, which means they will do a geotechnical report on the site, or they'll do flood assessment reports or arborist reports. They'll just hand over these reports to the contractor and say, right, now all of the risk is on you. You have to go design it, and then you will have to go build it. Is showing all of this red area is where the maximum amount of water is flowing, and this is actually a creek. This red area is the creek where all of the water from this area gets drained away and outside. Okay, so can you see this level here? This level, it says 72.5. What it means is that was the reduced level up until which the peak flood levels reached. So this, for a designer like you and me, what it means is your finished surface level cannot be any less than 72.5. If you're going to be designing a field that's going to be sitting less than that particular reduced level, what happens is your field is going to be underwater, or it's going to get washed away. So in order to avoid all that, you have to keep in consideration all of these factors. Any field that you're grading, or any earthworks model that you're doing, it has to be graded to a minimum of 1%. Why? Because if it's any less than 1% grade, it's not easy for the water to flow away from your site. When you grade the site to a particular angle, it gets the water drains away, and then you will have your drainage system drain around the lower end, so that it gets collected and then it gets taken away through the stormwater system. This is the earthworks. There are three types of grading that you can do on your earthworks or on your subgrade. So I'll show you what a one-directional grade is. If this is your flat ground, if you're able to lift your field only through one direction, which means there is fall only from point A to point B, or in just one direction, it means that it is a one directional fall, where water can flow through, or there is slope only in one direction. So this is called a one directional fall. The next thing is, if you're lifting up your field in one direction, and also if you're lifting up your field in direction 2, then there is slope in two directions, which means the resultant fall is along the diagonal. So this is called a two directional fall. And also there's a third one where they'll create a ridge in the middle, which means when water falls on the field, or when there's going to be rainfall, when water can drain away in two directions, and you will have drainage sections along both the side, and water can drain out of it. This is what I mean by how many cubic meters of soil needs to be cut. I will be able to allocate machines for it, saying, okay, if it's 500 cubic meters, or if it's just 100 cubic meters, I can allow smaller excavators. It can be a 5-ton or a 20-ton excavator. If it's going to be over 1,000 cubic meters, then I have to allow for a tractor and a scoop, or I'll have to allow for an elevating scraper there. So depending on the size of that, we only when you know the quantity of soil that needs to be cut or filled, I will be able to decide on the pricing for the estimate. So that's why I need the quantity for it. If you're going to be designing a drainage area for any field, you will have to keep into consideration 4 things. One is how much rainfall that particular area is going to receive. The next one is the slope. What's the slope? We already talked about grading the field. And then the next thing is the catchment area. And also the fourth thing would be the size of your pipe. So based on these things, you will be able to design your field. So this is what a synthetic grass carpet will look like. See in the back, it's got latex in it, and then there's yarn. The size of the yarn or the height of the yarn will keep varying depending on the type of the game. There'll be 60 mil, 40 mil, or whatever. So that's the height of the yarn. So inside this synthetic grass, there will be two types of infill in it. This is just a carpet itself. If you see that drawing here, there are two types of infill in it. So they'll put sand in it, which is called a stabilizing infill, and then they'll put crushed rubber on top of it, which is called a which is called a performance infill. Why? The reason for putting this crushed rubber in it is because when players are walking around or when they're running around, and if they fall head first, it will reduce the impact on or the injury that's going to happen to the player. So that is why this infill system is added. So players who have played on synthetic surface, they would have seen this. So this carpet will have holes in the behind. So now that you'll get a full picture of what I'm talking about, when rain falls on the surface, it will trickle through your rubber, your sand, and then it will find the holes in the surface, and if you have a horizontal surface, it'll run through that, and then it'll run through your horizontal surface, and it'll keep going further out. Okay. So when I say a synthetic grass system, it's not just this grass. There's another layer called a shock pad underneath it, and then there is drain cell. All of these things together is what is called a synthetic grass system. So anywhere around the world, if you want to lay a synthetic grass system, it has to be FIFA accredited. So it'll go under a lot of rigorous testing before it gets accredited, and before FIFA approves, saying that yes, this is a quality field and it can be played on. This shock pad layer is just a 20 or 30 mil foam layer that's again added in to take up the impact. When someone's falling, you can reduce the amount of impact that's happening. So that's why they add the shock pad system. And then the drain cell is also another plastic layer. It's just to take up or wash away all the water that's there. It's 90% void spaces. So all of this three system will undergo UV testing, and then it'll undergo Lisport testing, in which they will try and degrade it. It'll go for around 100 to 200,000 times of cycles, and even after that, if the yarn is still standing up, then it means the synthetic grass is good. So like this, it'll undergo a lot of testings, and once it's passed all the testing, then it will become a FIFA accredited synthetic grass system. This is my favorite part. So every day there's so much amount of construction that's going on in and around the world. Just by producing concrete or just by producing cement, we contribute to about 8% or more for the CO2 emissions in the world. Even in the construction field, we contribute to a lot of waste production. See this infill items that I was talking about, this rubber, it's actually recycled tire items. So they'll just crush it into 1 or 4 millimeters pieces. So when it rains or when it starts to flood, this infill will get washed away and it'll go into the waterways, which pollutes the waterways. And this synthetic grass carpet, it's plastic. So the problem is there is research going on to learn to recycle this, but it's not 100%. It's not in the market yet. So maybe 10, 20 years later, it'll still go to a landfill, but they're still trying to reuse it in different parts. In different parts, it's different items, but it's still not yet up to the mark.